People do tomorrow, or is that just, or is that everybody?
Hey, you can erase that.
You are no longer in Baker currently. True that. And you spelled your own name wrong.
Unless you want me to call you Mr. Baker.
No.
Mr. Baker, I like your tie.
Mr. Baker, fine guy.
Tell me about government.
Yeah, not the same. All right. So this is really a hodgepodge, a potpourri, if you like, of calculus ideas. It's like a buffet of calculus ideas, if you like. The only difference is you won't pick and choose. You'll take a little of everything. Okay. So here goes. First idea is using an initial condition. All of this should be, the whole way through is kind of, did we do that already? I think we did that already. It's kind of just a little deeper level of all this stuff, okay? So imagine if you had, yeah, that's what I want, yep. F double is given. I give you an F prime and an F fact, and I want you to go to F of X. How would you get to F of X? Antiderivative. In fact, you'll probably need to take an antiderivative twice. Because of that, you'll probably get two constants of integration. I was taught that you number them to communicate that there's a difference between the two. So here's what I mean. I could first anti-differentiate F double with respect to X. And when I do so, what would I be finding? F prime. Antiderivative once would undo one of the derivatives, getting me at F prime. If I anti-differentiate, 3x squared is fine. One of the things I want to get across today is make your life easier. For example, instead of integrating 1 over e to the negative x, I could just integrate e to the x. Okay, you would never work with hard functions when you can take a small step and make your life so much easier. All right, so what is the antiderivative of 3x squared? X cubed, and the antiderivative of e to the x? E to the x, and the minute I integrate, I get a constant of integration. Now, because looking ahead, I knew that I was going to get two constants of integration. I'm going to call that C1 for the first constant of integration. In order to find that constant of integration, I need an initial condition. What shall I use? The first one or the second one? The first one. In for the derivative. So where does the 3 go? In for f prime or for x? F prime is 3 and x is 0. Please don't fall into the temptation that thinking that C1 is 3, because not everything to the 0 zeroes out. For example, that e to the 0 actually is 1. Therefore, C1 is really 2, and the derivative now is complete. It is x cubed plus e to the x plus 2. So far, so good. Now to get to f, I will antiderivative of f prime. Antiderivative of x cubed plus e to the x plus 2 with respect to x is ... Who hit the first term? Sarah.
1.
Next term, Boyd. Next term, Jet. And the constant, let's call it C2. All right. How do I use the next initial condition to find C2? F equals 4. So 4 goes there. What does x equal, Sabrina?
0.
0, yes indeed. So 0 plus e to the 0 plus 0 plus C2. What's C2, anybody? 3. We are there. We are done. F of x equals x. Nope. Here's where my f was. I need to now just plug in my c. So f is 1/4 x to the 4th plus e to the x plus 2x plus 3. Wait. Get out your calculator. No, not yet. Never mind. Keep your calculator stashed. You don't need it yet. All right. Now, sometime then you're given a derivative and you can find the c and all is well. Sometimes, however, you get a function that's not integrable. That is to say, which can be integrated. Not everything can be integrated. It's possible that you have a lot of functions that have no antiderivative. In that case, then, you really go at it based as an area under the curve kind of approach. So, for example, if you're given this ugly derivative and this fact, and I wanted you to find f of x, the best you could do is an integral defined function. You with me? So, you might start by saying something like, I could do the derivative of f prime to get f. I think you'll agree that's a natural. If I want f, I'm going to integrate for sure. If I have an initial condition, besides using it to find the c, I can also use it as an anchor point to talk about where I know and where I want to get to. I know 2 and I want to get to some other point x, right? Now the minute I've used x there, this has to become a dummy variable, so u or v or something like that. I have at least one student who's kind of churchy, like me, and she refuses to use f. She doesn't want to say f of, she just said, I'm going to use w or something like that. I think that's cute. If you don't like f of u, feel free to use f of v, whatever. I don't care. All right, then. If you would anti-differentiate f prime using the fundamental theorem, wouldn't you anti-differentiate and put upper minus lower? So what would this be equivalent to? F of x minus f of 2. Now the whole idea is to find an expression for f of x. So let's isolate f of x. If you isolate this, then I would have to move that over. And so the initial condition goes in front. F of 2, which you could call f of 2, or you could call the value, isn't f of 2 equal to 1? So I could put a 1 in there, and then say plus the change. And that really is what's going on in that complicated expression is, hey, f is the starting point plus the change from that starting point gives me whatever ending point you want. Does that make sense? Okay. All right, then, let's talk one more case. Now both of these cases we're finding f at any x. This was actually finding f of x because you could take the antiderivative. This was finding kind of a quasi f of x because all you could do is say the change up to some certain point, but it couldn't be integrated. But they're both f at any x. F of x, f at any x. If you wanted f specifically at a number, well, then you can do things a little differently here. Say you had dy dx is 1/2 cosine of negative x, and f of pi equals 6. You wanted f of pi over 2. No calculator. One way to it is to do like we did in the first example. Find f of x, find c, and then just use to find f at pi over 2. Once you have f of x, you can find whatever you want. You can find f of pi over 2 if you want to. You with me? So it's going to look like the first one with one extra step. Let's start with if dy dx is this, then wouldn't y be the antiderivative of that? So the antiderivative of 1/2 cosine of negative x dx. Negative x. What will it cause me to have to do? Use some. Is there a way around that? There is. What is it? Cosine of negative x is x. This again goes to that idea of if you can make your life easier, do that. Luke is referring to the fact that cosine is even. Cosine looks like this. We know that f at any, I don't care where you put x over here, at any negative x, the y value there is exactly the same as at positive x. Always the same. Cosine of pi over 6 is the same as cosine of negative pi over 6. Cosine of whatever is the same as the negative. Now because of that, I could rewrite this as being equivalent to cosine of x. That's so much easier to anti-differentiate. Our use of problem is gone. Again, the point is, if you can make your life easier before your calculus, do that. What is the antiderivative? Negative or positive? 1/2 sine. Positive 1/2 sine plus c1 or just straight up c? Just see, we're only integrating once here. We're not going with the second derivative thing. It's just one constant in this problem, okay? Now we could use the initial to find the plus c. If f at pi over 6 is 2, then what goes where? 2 is the y, and pi over 6 is the x. What's pi over sine of pi over 6? 1/2. So altogether, that's 1/4. What's 2 minus 1/4? 1 3/4 or 7/4, whichever you prefer. Do you all agree? Okay. Therefore, y is 1/2 sine of x plus 7/4. So if I want y or f of pi over 2 was the question? Was that what the question was? Yeah. Okay. Then that's 1/2 sine of pi over 2 plus 7/4. What's sine of pi over 2? 1. What's 1/2 plus 7/4? 9/4. Okay, so in this case, they wanted it at a certain value. We could find the function completely, then find whatever that value they want. You with me? All right. If they want a specific f value in its calculator, then I could do this in a much quicker kind of way. I don't really care about finding the actual function and then plug it in. It's calculator active, fair game, so I could do this in a fundamental theorem way. What definite integral would you use? From where to where? Pi over 6 to pi over 2. Wouldn't this be y at pi over 2 minus y at pi over 6? Would? Are you with me? By fundamental theorem, antiderivative of dy dx is y at upper minus lower? Yeah? Okay. So f, or y at pi over 2 then, is y at pi, f at y, kind of using lots of mixed notations. Y and f apparently are the same thing. Y of pi over 6 plus the integral from pi over 6 to pi over 2 of 1/2 cosine of negative x dx, and then I could just plug it in. Is it worth getting out your calculator and plugging that in to see that it really is the same as 9/4, or no, you trust me? That's the spirit. I'll assume it's really trust, not laziness. All right, then. Any questions so far? Cool. Let's go on to another idea. Now, I struggled with what color to make this. It's derivatives and integrals, so I didn't know whether to make this pink or blue. It's whatever. It's a lot of both. These are going to be problems that I get questions on over and over and over again for the next 2 to 3 weeks until they start to click. So these tend to give students trouble. They're not. It's not always the same. You have to make some inferences and you have to connect the dots a little bit. Let me give you an example, a pretty good feel for what the harder ones might look like. All right, so the idea is you're given some function and it's not complete, and they give you a couple facts with which to fill in the blanks or figure out the missing pieces. All right, it's kind of like a mystery if you want to make it fun. So you have ax squared plus bx plus 1. It's some quadratic. And f of x has a relative min, a -1, -1. A and b then have to be some certain numbers. What are they? All right, now please, this is the biggest thing that causes people to miss these. The part that's the easiest is the one that's most overlooked.
Could I have ninth graders E through L report to the cafeteria? E through L ninth grade.
Okay? People, they're so juiced that they know, I know what relative min means. Here I go, derivative, boom, 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 boom. That they overlook the simplest thing. And that is that -1 is a point on the function. You should use it first. Forget relative min for now. This is a point on the function. And because of that, that tells me that when I put -1 in for x, that it comes out to be negative 1. That right there is a relationship already. The minute they give you a point, they're giving you a relationship. Negative 1 equals A minus B plus 1. Or even simpler, A minus B equals negative 2. Are you with me so far? Okay, use the point first, then get into the calculus. Now certainly because A and B are two unknowns, we need two relationships. Besides that equation, we need another. If it's a relative min for a quadratic, what must be happening? The derivative is? The derivative where is what? Derivative at negative 1 must be 0. Now we could have a relative min in a couple different ways, a flat spot or a cusp and stuff. But for a quadratic, there's no cusp on it. It's got to be that the derivative is 0, right? Not a dA. You with me? All right. Now if I were to use that then, the min fact, we translate it as the derivative at negative 1 must be 0. Well, to use that, then I need the derivative. F prime generally is 2ax plus b, yeah? If I use the fact then that the derivative is 0 when x is negative 1, then I get 0 equals negative 2a plus b. You tracking? Are you with me? Okay. I plugged in the x of negative 1 and the derivative is 0. That said, then, I get two equations. Negative 2a plus b equals 0, combined with that. Well, that's a system of equations. Before we go and solve that the easiest way, let's review all the math you've learned. Give me 5 ways, 5, to solve a system of equations. Substitution. Elimination. That does not solve the system. Good try. Graphic. Yep. Guess and check. The old guess and check. I guess so. I'll also add in Cramer's rule, inverse matrices. What else? Do you remember inverse matrices? Oh, that's unfortunate. So easy. You're going to need inverse matrices when you go to linear algebra. All right. You have so many ways. And I assume that you will use, which you will use.
Substitution.
Really?
Elimination.
It's so pretty princess. Elimination. Boom, the bees are gone, right? All right. So what do you get? Negative a equals negative 2. Therefore, a equals 2, and b must be negative 4 with 2 minus negative 4 being negative 2. Just 4. Okay? A equals 2, B equals 4, boom. All right, so this will involve collecting, using the facts, kind of inferring, making inferences to get a system of equations and then solving by some good algebra, all right? Try this one after I've got you started, okay? This is the one that students get most troubled with in the future. It's because they're giving you a fact that isn't used. Given f of x is a quadratic function with 0.03 and a relative max at 1,4, find the equation of the function. Very kind of nebulous. It's not really, here's the equation, boom, slap you in the face with it. It's kind of hidden in there. This is really the hidden part. If quadratic function, just again, to review for your big ideas of math, there are 3 common ways to write a quadratic. General form, factored form, or standard form. Yeah, sorry, that's ugly. When would you use standard form? If you knew the... How would this, if I give you this, the what? It goes forever, so it doesn't really have a center. I kind of know what you mean, but more, better. Come on, not the center, the vertex. Okay, the vertex is the problem, okay? If you knew the parabola's vertex, then this would be gold. Oops. This would be gold. What would factor form be good for? If you knew the
Zeros.
coordinates, the zeros, the x-intercepts. Okay, we use that when we know the zeros. Any other case, general form is good. Now this is a pretty common, thanks dude. This is a pretty common problem at calc and pre-calc levels. If you just know random facts, then you typically use general form. So we're going to use this. Use general form of a quadratic. You have to make that connection. Quadratic function means ax squared plus bx plus c, okay? If y equals ax squared plus bx plus c is the case, then we need to find a, b, and c to answer the question. They say, what's the equation? I need to know a, b, and c, right? Okay, so the first thing you do is use the points. Use them first and then get into the calculus. If you use 0, 3, that implies that 3 equals 0 plus 0 plus c. Right away, I know c is 3. And I can actually go back and put 3 in c's place, and now it's starting to be a little more like that previous one. I really only have 2 on this, right? If I use 1, 4, that implies that 4 equals a plus b plus 3, or that a plus b is 1. All right, now we're getting somewhere. Okay, we've found C, and we have a relationship between A and B. Now, surely we need another one. What's another relationship that I can use? There's a component there I haven't touched on yet. What is it? F prime. Yeah, the max. Surely the max, if there's a max at 1, 4, that implies something. What does it imply? The derivative where? At 1 is 0, okay? So to use that, I need the derivative. F prime is 2ax plus b. And then the numbers in there would be that 0 goes in for the derivative when x is 1. So that implies that 2a plus b equals 0. Do you agree? All right. So here's my equations. Capital A, capital B. Do you want to substitute, eliminate? What do you want to do?
Inverse matrices.
Inverse matrix. Okay, cool. Right on. All right. So the matrix 1, 1, 2, 1, A, B equals 1, 0. Yeah? Are you with me? This is good review. Extra credit for you. Right on. This equation, this system of equations is the same as this matrix equation. All right? Are you with me? Now the idea is that you invert, you find the inverse of matrix A. What is the inverse of matrix A? Do you remember how to find the inverse? Okay, you find the determinant first. What's the determinant of this matrix? 1 minus 2 or negative 1. That's the denominator of every component. It'll be a freaking miracle if I remember this, quite frankly. I haven't taught the people. So then, I think these guys, you do something with them, like you switch them, or you negate them. You switch these, but negate those, right? You flip these, and negate these. Oh yeah, let's do this. I like to figure it out myself.
Yeah, right.
All right, that's okay. We'll be able to check our work in a second. We're going to negate these. I think it's negate these. You with me? It'll be fine. This is great review. Okay? All right, now if the whole idea is if this is truly the inverse, then when you multiply this matrix by this matrix, you should get the identity matrix. Oh, that's good stuff, okay? So that when you multiply this matrix by this matrix, it's A plus 0B, or A, 0A plus B is B. Now the question is, does this work? Now remember, when you multiply, do you remember how to multiply matrices? Multiply a row times a column and add to get one result. So that's -1 plus 2 is 1. Now you go first row times second column. -1 plus 1 is 0. Then you go second row times first column. 2 minus 2 is 0. And second row times second column. 2 minus 1 is 1. Beautiful. That is the identity matrix. That is the inverse. And so that does yield A and B. Now, whatever I do to one side of the equation, I have to do to the other. But in matrix multiplication, order matters. So you have to put that inverse on the left. -1, 1, 2, -1. We're almost there. This is awesome. Okay, so would you please multiply these matrices for me?
No.
Yes? What do you mean no? No? Okay, row times column, add the components. -1 plus 0 is -1. Second row times that column, 2 is 2. Therefore, A is, and B is 2. Yeah, but we learned, or we reviewed. That's good stuff.
I can check the word.
Well, I've got a calculator. Your calculator could do this too. All right, cool. Good stuff. Good stuff. All right. This is a huge idea of calculus called curve sketching. This was a problem from the CU final 2 years ago. This was a question. They gave you all this information, and you were supposed to put it all together to get a good sketch of F. Do you feel like you could do this on your own, or should we talk through it together? I don't want to be just copy fest. Let's talk, and by talk, I mean you tell me. Okay? H is a polynomial. Cool. Odd function. What does that imply? Symmetric about the origin. Perfect. Okay? Function-wise, it means that any negative x is the opposite of f positive. Now, if they give you points, use them. H of 0 is 0. Boom. That's got to be the case. You'll find that an odd function must pass through the origin period. Actually, I take that back if it's kind of nasty up there for you. H of 1 equals 2. Now that's actually 2 points they just gave me. Because if it's odd, besides 1, 2, I also know -1, -2. Okay? All right. Here we go. The limit as x goes to -1/2 is -1.5. Now if it's a polynomial, then there's no holes or jump discontinuities. It's just whatever the limit is also the point. Do you agree? Okay. So this really, I could say, is like a point. -1/2, -3/2. -1/2, -3/2. -3/2. And again, odd. So what does that also tell me? 1/2, 3/2. As x goes to -infinity, h goes to infinity. So what does that mean as far as, what are they giving you? What's another phrase for that? End behavior. That's the end behavior. So does that go up and to the right, down and to the left, up and to the left? Down, what does that say? Up and to the left. It goes up and to the left. Okay, so it goes here. Are we interested in seeing how it's going to do that? This then also implies end behavior. What is this doing? down and to the right. The x's go right, the y's go down, right? That seems like that is in keeping with odd, at least. Are we cool so far? All right. First derivative test. What does this mean? This stuff. Okay, it tells me minimums. What else? Maximum. That was a softie. Not what I was looking for. What else? Decreasing, increasing behavior. Yeah? H is decreasing, increasing, decreasing. Right? Okay. So I have a min at -1, and it's decreasing before -1, increasing, and then decreasing, like that. Ooh. Oh, what a man. All right, then this. I might have to do a little erasing in a second. What does this tell me? Concave down on -1/2 to 0. And concave down on 1/2 to infinity. So concave down here. So what am I going to do here? What is this going to look like? How do I make, is it concave down the way I have it? No, that's concave up. All right, so how do I graph it so it's concave down? Like that? Yeah? Now, what about on the other side then? In order for it to match, I need the symmetry then. So if it's concave down here, it feels like on this side it's concave up to 1/2. And then does it also have that concave down from 1/2 on? Does it look concave down from 1/2 on? Yeah.
That's through the ninth graders.
Okay. All right. So that's the idea. A lot going on there. Good stuff. Good stuff. 2002, and then we'll move on. Go, go, go. I would like to see. I would like you guys to see. I have the first page. Do you have the first one done? So it's making inferences. F prime positive, what does that imply? I don't like it. What's increasing? F is increasing, okay? F prime is positive, F is increasing. What does that imply about how F5 relates to F4? F5 must be greater than F4. That implies then that F at 4 must be greater than, or F at 5 rather, F at 5 must be greater than 5. That's good. F double negative, that's a harder one to use. What does F double negative imply? F prime is decreasing. Okay. F prime is decreasing. Now, if F prime is decreasing, and F prime is the change in F, then that implies F changes are getting smaller. F changes are decreasing. Well, I need to look at the changes then. This change is 13. This change is 5. Therefore, this change must be less than 5. Now, if the next change must be less than 5, that implies that F at 5 must be less than 30. I can then infer, putting those together, that F5 must be between 25 from the first condition, greater than 25, but less than 30. You with me? All right, last but not least, do the verbal one. My goal is to you to understand calculus verbally, analytically, graphically, and numerically. All right, here we go. It's a great day. I was particularly happy that nobody left my room crying after the test. That's great. I cannot really say that was the case with the BC test. But those kids are a little tightly wound, I gotta tell you. Don't worry about them. So, all right. How are we doing? Are we ready? Yes? No? Up? Strangers in the night, exchanging glances, wandering in the night. What were the chances? Okay, by far the hardest part to this is the first step. What do you do first? You need to take the words and put them into math. What is that in calculus? A function changes at a rate of. What does that imply? What calculus? Derivative. The derivative, you could use dy dx, I suppose. You could use y prime. You could say f prime, whatever, is 2x. If they also give you a point on the curve, how do I find f? Integrate, yeah. F will be the antiderivative of f prime, so the antiderivative of 2x, which is x squared plus c. If the function is x squared plus c, and they tell me it passes through 1, 4, then what's the final answer? 3 is your final answer, or that's part of your final answer? X squared plus 3 is your final answer. 4 equals 1 squared plus c implies c is 3. Okay? All right. Christy, you please go out to the hall so you don't have an unfair advantage on the test. You may take your shopping. And here we go. We will do corrections on this. I'll probably have to give you more time tomorrow on this, but at least you'll be able to see it. What were the chances we'd be very glad? We're going to start transitioning into two types of assessments. I'll give you kind of short quizzes on straight up out of the book. Do you have a clue on the stuff you're learning in the book kind of stuff? And then the AP and the test will be more and more AP-ish. In terms of strategy, you don't really want to kill the straight up out of the booky kind of quizzes because the AP obviously is hard to kill. Stop it. Negative Nelly. Cherries, negative Nelly. Does everybody have a test in front of them? Okie dokie. Let's at least, oops, let me stop this before I start talking about the text.